Namaste student. Today we are going to do a problem related to tangent-radius theorem. So here let's recapitulate what tangent-radius theorem says. If this is a tangent, this is your point of contact and this is your radius, then radius is perpendicular to tangent. Remember, this theorem we call tangent-radius theorem. Now based on this one, we're going to do a problem. So here we have first problem. So here what the problem says, two concentric circles are of radius 5 cm and 3 cm. Concentric circle means there should be center common. Okay, so first one is your 5 cm, another is 3 cm. Now what they are asking, find the length of the chord of the larger circle which touch the smaller circle. So here we are taking, this is your larger circle and AB is the chord. Now this AB touches the smaller circle. So that means for larger circle this is your chord and for smaller circle it is a tangent. Have you seen? Two different things. So here what we're going to do, they are asking that to find the length of this one. So what we're going to do, we'll join this part. So why are you joining this one? Because if we'll join this one and if we'll join this point of contact here, you will get one right angle triangle. And we have the value because OA is a radius of the bigger one and it has given here 5 cm. And given name here P, then OP is your what? Radius of the smaller one. And this one also has been given. This is 3 cm. That means by Pythagoras theorem, we can find the value of AP. Okay, we'll use that one. Now question will answer, this diagram will be given to you. No, diagram you have to draw by your own. Read the question and draw the diagram. So now we'll proceed. We have now this diagram. So what they have, this is as a problem, so solution we're going to do. So here we have OA, that is 5 cm, OP 3 cm, and AB we need to find. Okay, AB we need to find. We know what we know. We know what? Tangent to a circle is perpendicular to the radius. Yes, through the point of contact. Okay. Now question will answer, shall I write this bigger, this much statement? No need to write. Just to skip this one, you can write that by Tangent-Radius Theorem. You can use this one also. Okay, so we can say that by Tangent-Radius Theorem, that means OP perpendicular to your AB. Therefore by Pythagoras theorem, we can find the value what? AP. Look at here, by Pythagoras theorem, this is your 90, that means opposite of this one is hypotenuse, and hypotenuse square equals to what? AP square plus OP square. So AP square can be written as what? OA square minus OP square. So by Pythagoras theorem, directly we can write here AP equals to root over OA square minus OP square. Now you substitute the value. Here we have 5 square minus 3 square. So we are getting here 25 minus 9 and we are getting 16, and 16 will give us 4 cm. Here we'll get 4 cm. Okay. Now they're asking us to find what? AP value. We have AP value. So how are you going to find this one? we know, remember that what from class 9, that what perpendicular to the chord bisect the chord, but perpendicular from the center, perpendicular from the center to the chord bisect the chord. So we know what one more thing, that perpendicular drawn from the center to the chord bisect the chord. Therefore, AB equals to what? 2 times of AP. This implies 2 into 4 centimeter. That means 8 centimeter. This is your answer. Okay. Now we have another problem. We'll go for the another problem. So here we have, you can see the problem. So let's read the problem. Prove that the tangent drawn at the ends of a diameter of a circle are parallel. That means here it is one kind of theorem, but let's prove this one as a problem because we're going to use the theorem, Tangent-Radius Theorem. This one. Okay. So let's start. So what they have given here? They have given that PQ is a diameter, and what they're saying that two tangent will be drawn through point P and Q. That means tangent drawn at the ends of a diameter. That means this is your diameter, and end means this is your end of the diameter. This one P is the end and Q is the end. So through that P and Q, two tangent will be drawn, and they are asking that two tangent must be parallel to each other. That means they have given that AB and CD are tangent at P and Q respectively, and you need to prove that these two tangent means AB must be parallel to CD. We need to prove this, and we know that what we know, that if we take two parallel line and one transversal, then if these two are parallel and this is your transversal, then alternate interior angle must be equal. Okay. Or if alternate interior angles are equal, then these two lines must be parallel. We'll use that concept. Okay. We need to show that A, Q, P, this one equals to this one, or this angle equals to this. Any one of them you show. Okay. So we'll see. So we'll start. We don't need any construction here. So we'll directly write, we know what we know. We know tangent to a circle is perpendicular what to the radius through the point of contact. Okay. So here, so now question will arise, sir, why you are using again this system? See, we don't know that which teacher will going to check your copy. So whatever our target is, that write the statement. Okay. So no one will going to cut your marks. So here we have this one. So that means we can write here OQ. Therefore we can say that OQ perpendicular to what? AB, and another one OP perpendicular to your CD. This implies we can write, this means we can say that OQA, angle OQA equals to what? 90 degree. this imply angle. Sir, we can write this one also. Yes, we can write, but our target is this and this. If we need to take the target this one and this one, then you write this one. Your choice would be there. Okay. So we are taking this one. So now we have already taken 90. Our target is this one. So we'll write here OPD equals to 90 degree. This is the number 1. This is the number 2. From 1 and 2, what we can say? See, this is equals to 90 degree. This is equals to 90 degree. This implies angle OQA equals to angle OPD. Okay, from 1 and 2. But what? But angle OQA and angle OPD are alternate interior angles. Therefore, by alternate angles, axioms, we can say that AB parallels to CD. This we need to prove. Okay. Thank you.